It's nothing.
So is Aaron's chance to grace.
Yeah, we can laugh about that. Look at this little sheet here, ladies and gentlemen. All right, these are what are called the properties of addition and multiplication. You'll probably never use them again in your life. Somebody will ask you a few things about them at some point. Did they come up on maths test at any point?
Yeah.
No.
Oh, Fish says yes.
Caleb, stop lying.
I feel like you did. Not just okay.
I told you this before, and I will say it again. This is part of this is upper level thinking, which I know is probably going to leave some of you in the dust. Well, most of you in the dust. Well, maybe none of you will catch on any of this, but what you have to understand is you do a lot of things in math that you've been doing since you've been in preschool, kindergarten, whatever, but you don't really know why you're allowed to do them, and that's what this tells you. These are things you can do in math and why. When you get into geometry, which will be sooner rather than later, believe it or not, in the next 2 years or whatever it is, you have to prove a whole bunch of stuff based on things that you know, and that's kind of where this comes from. So you need to be able to look at this, and it's really simple if you just look at the patterns there. For example, if you're talking about the identity property of addition, what do you see happening in both of these cases here? Yes, you add 0. Okay, or the identity property of multiplication deals with when you see something getting multiplied by 1. What it basically means is, what do you add to something to get to itself? What do you multiply something by and it stays itself? Those two things are. So if you see something like this and the book says, what property is this? 17 times 1 equals 17. You just can make the connection that that is multiplying by 1, so it is the identity property of multiplication. The commutative property of addition. What do you see happening there? It's a plus b equals b plus a. What has happened to those numbers? They have changed places. 5 plus 2 is the same as 2 plus 5. And that's the same thing for multiplication. They change places. People get these two properties mixed up all the time simply because they don't look at it. The associative property, what happens in that? The only thing that changes in the associative property is the parentheses move. It goes from this. These letters stay in the same order. 1 plus 2 plus 3, 1 plus 2 plus 3. The only thing that's changed is which ones you associate together first. And the parentheses does that. Do you get that? I don't want to beat the proverbial dead horse. Now, look at your book here. Let's see if this can make sense to you. Look at page. Is there like one in here? Look at page 66. Is everybody at 66? So you look at letter A. It says to identify what property is illustrated there. Now, what do you see there? Madison, do you not have a book? Or you? Oh. Does Leighton not have a book? Is only one of your books open?
Yeah.
What is going on there? You look and you see 5 plus 9 plus 8 in parentheses, and then you have parentheses 5 plus 9 plus 8 in parentheses. The first question you ask yourself, are the numbers in the same order? Yes, it's 5 plus 9 plus 8, 5 plus 9, 8. The only thing that has changed is the... So which property is it? Look at letter B. 0 plus 10 equals 10. Which one up there has zeros added to something? This is not difficult. Letter C. 15 times 3 equals 3 times 15. Which property do they flip-flop, move, do whatever? Yes. Letter D. 17 times 1? What? Letter E. Wait, it says tell whether each statement is true or false. Justify your answer using the properties. Assume that all variables represent real numbers. Is A times B times C with the parenthesis around the AB the same as A times B times C with the parenthesis around the BC? Will that give you the same answer? Will that be true? Can you do that, Anderson? Did you say yes? Because of what property? See how easy this is? What about letter F? Is M minus Z equals Z minus M? Chase? Huh?
What?
Does m minus z equal z minus m? Which property says that when you subtract, is there a commutative property of subtraction, Chase?
No.
So, can you do that?
No.
No, thank you very much. W plus 0 equals W. True or false? Shannon?
False or true?
Yes, it is. False or true? Which one?
True.
True. Now, let's look at letter H. 18 plus 7x plus 4. Now, see if this makes any sense to you. First of all, what does the direction say to do? Simplify and justify. If you're asked to simplify that, first of all, do you see the equal signs, Emily Anderson? No, you're not going to get a single answer, but you can simplify it by doing what? What can you do there, Bri? Andrew? Which two?
18 plus 4.
Now, but they're not next to each other. You do have to move them. But you can't do that for no reason. What if it doesn't work? What if that's not true? So somehow, ladies and gentlemen, I got to get the 18 next to the 4 and be able to justify it using the properties I know. Any suggestions? Aaron? Which one am I going to commute?
4 and the 7 next.
All right, because of the commutative property, watch, I'm going to rewrite what I have here, plus 4. I know that that equals, Aaron said I can flip-flop these two. I can say 18 plus 4 plus 7x. Correct? Because of the commutative property. And then what can you do from there? Add 18 plus 4, it is plus 7x. And then it's simplified because you can do the commutative property. Sometimes people gasp in amazement at that.
Two.
What's that? I think I'm done because I don't think I can take any more. Your assignment, children, is lesson number 12. Somebody say all. All. Yeah. That's a lot.